chapter 4.6 is the inverse of a function. And to me, it always reminds me of like a photograph's negative. I don't know if you've ever seen one of those before, but it's kind of the opposite. I thought this was cool. So this guy drew a negative of Marilyn Monroe, and so when you take the negative of him, it's the positive of her. So I thought that was kind of cool. But so anyway, that's kind of what I think of when I think of inverses of functions. So we've learned how to find an output given a specific input, but how would we find an input when given a specific output? So basically, again, inverse, we're kind of doing the opposite. So kind of keep that in mind as we do this. So let f of x equal 2x plus 3. Solve y equals f of x for x. All right, so instead of solving for getting y by itself, we're going to get x by itself. So we have, let's see, basically y equals 2x plus 3. We subtract 3 from both sides. So I have y minus 3 equals 2x. Divide by 2, and I have x equals y minus 3 over 2. And then it says find the input when the output is negative 7. So this is when we plug it in after we've solved for x. So I have x equals negative 7 minus 3 divided by 2. So x is negative 10 over 2. X is negative 5. So all I did is get x by itself and then plug in. Okay, so I want you to try that. So go ahead and pause your video. All right, so solving for x again. First of all, I put y here because then that helps me to kind of keep that straight a little bit. And if I'm solving for x, I'm going to add 2 to both sides. So I get x equals y plus 2. And then find the inputs when the output is 2. So x equals 2 plus 2, x equals 4. So if I plug in 4 for x right here, I'll get 2, all right, which is what my output is, if that made sense. I hope that made sense. Okay, so here I have y equals 2x squared. Divide both sides by 2, and I have x squared equals y over 2. Now I'm going to take the square root of both, and in this case, we are going to have plus or minus y over 2. So when we take the square root of that, well, we did take the square root of that, but I have plus or minus 2 over 2, which equals plus or minus 1. So if I put 1 in here, I get 2. If I put negative 1 in here, I get 2. All right. Notice that these steps undo each other. Okay, so functions that undo each other are called inverse functions. And so we did that at the first. So we had 2x plus 3. We solved for x, okay? And then we kind of flip-flop the x and the y, all right? So we change x and y around, and then, okay, let me back up. You take the original function, you make this y, you make this x, and then you solve for y. You solve for the opposite thing that you've got, okay? And that's your inverse function. Okay, because inverse functions interchange the input and output values of the original function, the domain and the range are also interchanged. So that's if you graph one of the functions and then you switch the x and the y values around, you flip-flop them and you graph it again, you're going to graph the inverse function. So for example, here's 2x plus 3, this is one we've been looking at. Here's the x values. If we plug in, we have the y values. Well now, if you flip-flop, here we've got, you can see, these are now the old y values are the new x values. The old x values are the new y values. And it looks like this on a graph. So what I want you to notice here, we graphed both. The An inverse function is the reflection of the original function over x equals y. So it's not reflected over the x-axis, it's not reflected over the y-axis, it's reflected over the line x equals y. All right. So finding the inverse of a function, this is just like solving for x. So I can say y equals 3x minus 1, and when I'm finding the inverse, I flip-flop these two. So now I have x equals 3y minus 1, and I'm solving for y. So I add 1 to both sides, and I have x plus 1 equals 3y divided by 3, and I have y equals x plus 1 over 3. We could also say g of x, the inverse, is x plus y over 3. Okay. So I want you to go ahead and try these. So go ahead and pause your video. All right. So again, we're just flip-flopping. I'm going to make this x. This is going to be y, and I solve for y. This is exactly like solving for x that we did in the first problem. I'm just flipping them so that I can remember to solve for y. I don't know if that makes sense. Okay, so y equals x over 2. That's my inverse function. Okay, right here, I'm going to flip-flop. I have x equals negative y plus 1. I subtract 1 from both sides, and then I multiply both sides by a negative. I get y equals negative x plus 1. And then over here, I'll get x equals 1/3 y minus 2. Add 2 to both sides. X plus 2 equals 1/3 y. And now I multiply both sides by 3. I get y equals 3x plus 6. All right. I am going to cover this next part in the next video.